Here is a question that sounds like something you'd find on a conspiracy website, but turns out, when you follow the evidence carefully, to be one of the most serious and underexplored questions in all of human science. What if this isn't the first time? What if the civilization you live in, with its cities and its satellites and its 10,000-year arc of recorded history, is not the first attempt? What if, before the Sumerians scratched the first cuneiform into clay, before the Egyptians piled stone on stone, before the first agricultural village was established in the Fertile Crescent, there was something else? Something that rose, achieved a level of complexity we have not yet matched, and then fell, so completely, so catastrophically, that almost nothing remained? Not because the story was hidden or suppressed, but because 10,000 years is long enough that stone crumbles, wood rots, metal corrodes, and the sea rises to swallow the coastlines where most people have always lived? What if the question is not whether civilization can end? We know it can. We have abundant evidence. But whether it has ended before, in a way that left our ancestors starting from scratch in a world whose previous tenants had vanished. This is not a fringe question. It is a question that several serious geologists, archaeologists, geneticists, and climatologists have spent careers investigating from different angles, accumulating evidence that points uncomfortably in the same direction. The direction is this: human history as we teach it assumes a baseline. It assumes that before about 10,000 years ago, humans were hunter-gatherers, cognitively modern, but technologically simple, living in small bands, leaving no permanent infrastructure. And then, in the Neolithic, something changed. Agriculture appeared, more or less simultaneously, in several parts of the world. Permanent settlements followed. Trade networks emerged. Writing was invented. Cities arose. Civilization, as we understand it, began. That is the conventional story. It is the story in the textbooks. It is the story that has dominated academic archaeology for a century. And there are growing cracks in it. Not dramatic cracks. Not the kind that make newspaper headlines or force a complete rewrite of the curriculum. The kind that appear at the edges of the evidence, in the genetic record, in the climate data, in the archaeology of sites that don't fit the model, in the mathematics of how complex societies actually work and what happens when they break. This video is going to follow those cracks. Not to arrive at a sensational conclusion that some ancient advanced civilization built the pyramids with laser cutters before being destroyed by a superweapon. That story is not supported by evidence, and it's not the story I'm telling. The story I'm telling is stranger, more scientifically grounded, and more unsettling than that. It's the story of what the evidence actually says about the possibility of civilizational resets. Moments when the complexity and connectivity and accumulated knowledge of human societies was catastrophically reduced, sending survivors back toward the beginning, with little or no memory of what had been lost. It's a story about ice cores and genomes, and ocean sediments, and the mathematics of societal collapse. It's a story about the specific event 12,900 years ago that may have ended an entire chapter of human development. And it's a story about what it means that the archaeological record before that date is almost entirely missing. By the end of this video, you're going to think about human history differently. Let's start with the thing that almost nobody talks about when they talk about human prehistory: the timeline. Chapter 1: The Timeline Problem. Modern humans, Homo sapiens with fully modern anatomy, have existed for at least 300,000 years. Let that number sit for a moment. 300,000 years. The anatomical features that define us, the high rounded skull, the small brow ridge, the flat face, the chin, appear in the fossil record in Africa at least 300,000 years ago. And some features we associate with modern humans may go back 400,000 years or more. The most ancient fully modern human fossils from Jebel Irhoud in Morocco are dated to around 315,000 years. Cognitively modern behavior, the use of symbolic thinking, the production of art, the making of complex tools, the evidence of long-distance trade in materials, is somewhat more recent but still extraordinarily old. The Blombos Cave in South Africa contains ochre engravings that are at least 75,000 years old. Shell beads used as jewelry date to 130,000 years in North Africa. The Pinnacle Point Cave shows ochre processing and complex tool making from at least 164,000 years ago. Whatever cognitive threshold produces art and trade and symbolic communication was crossed by some humans somewhere between 100,000 and 200,000 years ago. Here is the question this timeline raises, and it is one of the most genuinely puzzling questions in anthropology. If anatomically and cognitively modern humans have existed for 300,000 years, why did it take 290,000 years to invent agriculture? Agriculture is, by most measures, not a difficult technology. It requires no exotic materials. It requires no specialized mathematical knowledge. It requires the observation that plants grow from seeds, an observation that any person who has spent significant time in the natural world would make repeatedly. It requires the decision to stay in one place long enough to tend those plants, which is a lifestyle choice with clear advantages. And it requires the gradual selection of high-yield plant varieties through the simple act of choosing which seeds to plant next year. This is not quantum mechanics. This is watching a plant grow from a seed and deciding to do that on purpose. And yet, in the conventional story, modern, humans went roughly 290,000 years without doing this, without independently domesticating any significant crop plant, without building any permanent settlement, without developing any writing system. And then, in a period of roughly 2,000 years, between about 10,000 and 8,000 years ago, agriculture appeared in at least 5 geographically separate regions, more or less simultaneously. The Fertile Crescent, the Yangtze and Yellow River valleys of China, the highlands of New Guinea, Mesoamerica, Sub-Saharan Africa, independent developments, not connected by trade or communication, all at roughly the same time. After 290,000 years of nothing, in a 2,000-year window, simultaneously. The conventional explanation for this is climate. The end of the last glacial period, the warming that began around 15,000 years ago and was largely complete by 10,000 years ago, changed the availability of wild resources and created conditions more suitable for settled agriculture. Dense stands of wild cereals expanded into new regions. The stabilization of sea levels made permanent coastal settlements more viable. The warming allowed a broader range of cultivable plants to thrive in temperate regions. In this explanation, humans didn't invent agriculture earlier because the climate didn't permit it. This explanation has real merit and real problems. The merit: it is true that the climate changed dramatically, and it is true that this change created new possibilities. The Sahara was a green, well-watered savanna between roughly 11,000 and 5,000 years ago, a period called the African Humid Period, or the Green Sahara. Sea levels were dramatically lower during the glacial maximum, exposing enormous areas of continental shelf. The distribution of resources was genuinely different. The problem? Modern humans lived through multiple glacial cycles before the Holocene. The second to last glacial maximum was about 140,000 years ago. The interglacial period that followed, the Eemian, from roughly 130,000 to 115,000 years ago, was as warm as the Holocene, and in some respects warmer. Hippopotamuses lived in the Rhine Valley. Forests covered what is now the Sahara. Sea levels were slightly higher than today. The climate was, by any measure, as suitable for agriculture as the early Holocene. And yet, no agriculture during the Eemian, no permanent settlements, no writing, no civilization. The cognitively modern humans of 125,000 years ago, living in a warm, resource-rich interglacial world, did not develop agriculture. The cognitively modern humans of 10,000 years ago, in a climate broadly similar to that of 125,000 years ago, developed it simultaneously on multiple continents. The simplest explanation for the difference between those two periods is not climate. It's something else. One possibility, the uncomfortable one, the one the mainstream narrative resists, is that the humans of 10,000 years ago were not starting from scratch, that they were rebuilding, that they had a cultural memory, however degraded, however fragmentary, of a more complex way of organizing society, that they did not take 290,000 years to figure out that seeds grow into plants. They already knew. They had known for a long time. And the reason they were apparently starting over around 10,000 years ago is that something, before that date, had drastically reduced the complexity of human society, had sent the survivors back toward the beginning, carrying fragments of knowledge with them, building again from the ruins. But let's push on the climate explanation a bit more before we abandon it, because it deserves fair treatment. The argument is that the Holocene differed from previous interglacials, not just in temperature, but in stability. Previous warm periods, including the Eemian, were followed by relatively rapid returns to glacial conditions, while the Holocene has maintained relatively stable, warm conditions for more than 11,000 years. In an unstable climate, there may be no incentive to invest in agriculture because a single bad decade could kill your entire crop before it had any payoff. Investing in the kind of multi-year projects, field preparation, seed selection, irrigation, that agriculture requires only makes sense if you expect the climate to remain stable enough to reward that investment. This is a genuinely good argument. Climate stability as a precondition for agriculture, not just climate warmth. It addresses the Eemian paradox more directly than simple temperature comparisons. And yet there is a counter to it. The climate of the early Holocene, The period between 12,000 and 8,000 years ago, when agriculture was being independently developed across the world, was not uniformly stable. It was interrupted by multiple cold events, including the Younger Dryas itself, which ended around 11,600 years ago. The 8.2 kilo-year event, a severe cooling episode around 8,200 years ago, and several smaller oscillations. Agriculture in the Fertile Crescent was developing during and immediately after the Younger Dryas, one of the most severe climate disruptions of the post-glacial period. The stability argument has some force, but it cannot fully explain why agriculture persisted and spread through a period of significant climate instability. The most honest answer to the timeline problem is that we don't fully know. The climate argument is partly right. Human behavioral complexity evolving toward a threshold may be part of it. Population growth creating resource pressure may be another factor. But the simultaneity, 5 independent agricultural origins in a 2,000-year window after 290,000 years of nothing, remains a genuine puzzle. One possibility, the uncomfortable one, the one the mainstream narrative resists, is that the humans of 10,000 years ago were not starting from scratch. This is the reset hypothesis, and the evidence for it is more substantial than most people realize. Chapter 2: What the Genome Remembers. Every human alive today carries in their DNA a record of the population history of our species. The genome is a document. It records births, deaths, migrations, and bottlenecks. Moments when the human population was drastically reduced, leaving genetic signatures that persist thousands of years after the event. Reading this document is the work of population genomics. And in the past 20 years, advances in ancient DNA extraction and sequencing have allowed geneticists to read increasingly precise records from the bones of ancient people. The results have been, in several respects, deeply surprising. The most important finding for the purposes of this video is what the genetic record says about human population sizes over time. Modern genetic diversity studies suggest that the effective population size of the human lineage has been remarkably small for most of our history, much smaller than the actual population, because effective population size is reduced by bottlenecks, by inbreeding, by population structure, and by events that drastically reduce genetic diversity. The details are complex and actively debated, but the broad picture is consistent across multiple independent analyses. The human lineage has passed through multiple severe genetic bottlenecks, moments when the total number of individuals contributing to the gene pool was extremely small. The most famous of these is the Toba bottleneck hypothesis. Around 74,000 years ago, the Toba supervolcano in what is now Sumatra erupted in the largest volcanic event in at least 2 million years, possibly the largest in 27 million years. The eruption ejected an estimated 2,800 cubic kilometers of material into the atmosphere. For comparison, the 1980 eruption of Mount St. Helens ejected about 1 cubic kilometer. The 1815 eruption of Tambora, the largest in recorded history, responsible for the year without a summer, ejected about 160 cubic kilometers. Toba was in a different category. The sulfur dioxide injected into the stratosphere would have caused a global volcanic winter lasting several years, with temperature drops of several degrees globally and potentially catastrophic consequences for vegetation and the animals that depend on it. Some genetic analyses have suggested that the human population fell to as few as 3,000 to 10,000 individuals following the Toba eruption, a near-extinction event that left a severe genetic bottleneck visible in the modern human genome. This remains disputed. Some researchers argue the bottleneck is real, but may predate Toba, and that human populations in Africa may have been shielded from the worst effects. But the genetic evidence for a severe population reduction in the period between about 100,000 and 60,000 years ago is not seriously contested. That is the famous bottleneck, but it is not the only one. More recent genomic analyses using increasingly sophisticated statistical methods to reconstruct ancient population sizes from modern and ancient DNA have identified additional signatures that don't fit the standard model of smooth, gradual population growth from the Holocene onward. Several studies have found evidence for a population crash or severe stagnation in the period between roughly 15,000 and 10,000 years ago, precisely the period spanning the end of the last glacial maximum and the beginning of the Holocene. This is the period when, in the conventional story, things are getting better. The climate is warming. Resources are becoming more abundant. The conditions for population growth are improving. You would expect population size to be increasing. And yet the genetic signal, in some analyses, suggests something more complicated. Not a simple, clean bottleneck with a clear single cause, but a pattern of regional population disruptions, connectivity losses, and diversity reductions that suggest something severely disrupted human populations in this period. Not everywhere at once, not every lineage, but broadly, across multiple geographic regions, the genetic record of this transitional period is not simply one of growth and expansion. The most dramatic recent finding in this category came not from population genomics, but from direct ancient DNA analysis. Studies of ancient human genomes from the period before 10,000 years ago, samples from Europe, the Near East, and East Asia show a striking discontinuity. The people living in Europe between roughly 40,000 and 15,000 years ago, the people who made the spectacular cave art of Lascaux and Altamira, who crafted the Venus figurines, who built the complex symbolic cultures of the Upper Paleolithic, are largely not the ancestors of the people who rebuilt Europe's population after the glacial maximum. Let's be specific about who these people were, because describing them simply as cave art people obscures the depth of what was lost. The Gravettian culture, which flourished across Europe between roughly 33,000 and 21,000 years ago, wove textiles. We know this from impressions of woven fabric found in fired clay at sites in the Czech Republic. They were the earliest known textile producers by thousands of years. They conducted elaborate burials, interring their dead with ivory jewelry, ochre, perforated shells, and carved animal figurines, representing a significant investment of skilled labor in funerary ritual that implies belief systems of real sophistication. The Venus figurines, produced across an area spanning from France to Siberia, a distribution spanning roughly 8,000 kilometers, share a consistent symbolic vocabulary that implies long-distance communication and shared cultural frameworks between communities, separated by enormous distances. These communities were in contact with each other. They shared symbols, technologies, and possibly stories across an area larger than modern Europe. The obsidian tools found at Central European Gravettian sites came from sources 800 kilometers away. Shells found at inland sites came from the Mediterranean coast. These are not isolated bands. They are nodes in a network. And networks, when they collapse in ways that leave almost nothing behind. There was a massive population turnover. The Upper Paleolithic Europeans largely disappeared from the genetic record. Their genes are found in only small proportions in post-glacial European populations. Something happened to them. The people who came after the event, the Mesolithic and early Neolithic Europeans, were substantially different genetically, suggesting they were either a surviving remnant of a different population or a group that moved in from elsewhere to repopulate a landscape that had been emptied. This is not controversial. This is well-established ancient DNA science, published in leading journals by large international research teams. What it implies is that the population of Europe, one of the most archaeologically well-studied regions of the world, experienced a catastrophic reduction at the end of the last ice age, followed by repopulation by a different group. A population reset in the most literal genetic sense. Europe is not an isolated case. Similar discontinuities appear in the ancient DNA record from the Near East, from South and Southeast Asia, and from the Americas. The story the genome tells about human populations in the period between 15,000 and 10,000 years ago is not a story of smooth continuity. It is a story of disruption, discontinuity, and rebuilding. The question is what caused it. Chapter 3: The Fire from the Sky. Younger Dryas. In June 2018, a scientific paper appeared in a journal called Scientific Reports, part of the Nature Publishing Group, that described, in careful and methodical language, the largest cosmic impact event in human history. Not a meteorite, not an asteroid, something worse. A comet, or more precisely, a fragmented comet, a debris swarm from a disintegrating object that struck or airburst across a wide swath of the northern hemisphere approximately 12,900 years ago, initiating a climate catastrophe that lasted roughly 1,300 years, ended a major civilization of the Pleistocene, and may have reset the developmental trajectory of human culture across the globe. This event is called the Younger Dryas Impact, and the evidence for it has been building for nearly 2 decades in a series of papers by a group called the Younger Dryas Impact Hypothesis Team, a consortium of researchers from geology, astronomy, physics, and archaeology who have been assembling a case that many of their colleagues find compelling and others find contested. Let me give you the evidence because it is more extensive and more specific than most summaries suggest. The Younger Dryas is itself uncontroversial. It is a well-established and precisely dated climate event. Around 12,900 years ago, the gradual warming trend following the last glacial maximum suddenly and dramatically reversed. Average temperatures in the North Atlantic region dropped by as much as 15 degrees Celsius within decades. Glaciers that had been retreating began re-advancing. The landscape that had been greening reverted to tundra. This cold period lasted roughly 1,300 years, ending just as abruptly around 11,600 years ago when temperatures rebounded to near modern levels within decades. The rapidity of this reversal, in both directions, is remarkable. Climate systems are large and have enormous thermal inertia. For temperatures to shift by 15 degrees in the North Atlantic within decades is extraordinary. The conventional explanation has been the disruption of the Atlantic thermohaline circulation, the conveyor belt of ocean currents that transports heat from the tropics to the North Atlantic, by a sudden, massive freshwater pulse from the melting of the Laurentide ice sheet. Enormous glacial lakes drained catastrophically into the North Atlantic, freshening the surface water enough to shut down the density-driven thermohaline circulation, dramatically reducing heat transport to high latitudes. This mechanism is real and well supported by ocean sediment evidence. What it doesn't explain, on its own, is the specific timing of 12,900 years ago, which coincides with something very specific in the geological record. At sites across North America, Europe, the Middle East, and beyond, sites spanning 4 continents, there exists a thin sedimentary layer that dates precisely to 12,900 years ago. This layer is unlike the surrounding sediment in several respects. It contains abnormally high concentrations of platinum, iridium, osmium, and other platinum group elements that are extremely rare in Earth's crust, but concentrated in extraterrestrial objects like asteroids and comets. It contains nanodiamonds, microscopic diamonds that form under the extreme pressure and temperature of high-energy impacts and explosions. It contains magnetic microspherules, tiny spheres of iron-rich material that form when rock is vaporized and rapidly solidified, characteristic of impact events. It contains cosmic spherules, rounded particles that originate from space, found nowhere else in the stratigraphic sequence. And it contains something called high-temperature melt glass, vitrified material formed when rock is heated to temperatures exceeding 2,200 degrees Celsius. Similar material is found at known nuclear test sites and at large meteor impact craters. It is not produced by conventional geological processes. It is not produced by volcanic eruptions. It is produced by impacts and detonations. This layer, containing platinum, nanodiamonds, magnetic spherules, cosmic spherules, and high-temperature melt glass, appears at more than 50 sites across 4 continents, all dating to the same narrow window around 12,900 years ago. One of the most dramatic of these sites is Göbekli Tepe in southern Turkey. If that name sounds familiar, it should. We'll get to it in a moment. But the younger Dryas boundary layer at Göbekli Tepe is particularly striking because it appears in stratigraphic context with one of the most archaeologically significant sites in the world. The impact signature also appears at Hilazon Tahtit Cave in Israel, at Abu Huraira in Syria, one of the earliest farming villages ever identified, and at Murray Springs in Arizona, where it coincides precisely with the extinction of mammoths and horses at the site. At every site where both are present, the impact layer sits immediately below the extinction horizon for the North American megafauna, the woolly mammoths, the horses, the ground sloths, the giant beavers, the saber-toothed cats, that disappeared approximately 12,900 years ago. The Abu Huraira site deserves particular attention because it sits at the intersection of the impact hypothesis and the origin of agriculture story in a way that is almost uncomfortably precise. Abu Huraira, now submerged beneath a Syrian reservoir, was excavated in the 1970s before its destruction. The archaeological record at the site showed something remarkable. The inhabitants were in the early stages of transitioning from foraging to farming, cultivating wild rye and other cereals, when the younger Dryas boundary layer appears in the sediment. Immediately above the impact layer, the farming activity ceased. The people who had been beginning to plant crops abandoned the effort. The site reverted to a hunter-gatherer occupation for several generations before agriculture eventually resumed, roughly 1,000 years later after the younger Dryas ended. Abu Huraira is a snapshot of the reset in action. An agricultural transition that was beginning, that was at the earliest, most fragile stage of the multi-generational process, by which a community shifts from foraging to farming, was interrupted by an external catastrophe and had to be restarted from scratch. If this happened at one site at the most vulnerable moment in the agricultural transition, it almost certainly happened at many others. Every community that had been moving toward greater complexity and was struck by the younger Dryas event, whether through the direct effects of impact, through the subsequent 1,300 years of cold, or through the cascading social disruptions that follow resource collapse, would have had that transition reset. The younger Dryas impact hypothesis proposes that a fragmenting comet, possibly associated with the Taurid meteor stream, entered the inner solar system and distributed multiple impacting fragments across the northern hemisphere. Not a single crater-forming impact, but a distributed airburst and surface impact event spread across a wide geographic region. The energy release would have been enormous, potentially comparable to thousands of nuclear weapons detonated simultaneously. The immediate effects would have included firestorms across large areas of North America, supported by the presence of charcoal and soot in the boundary layer. The secondary effects, injection of dust and aerosols into the atmosphere, destabilization of the Laurentide ice sheet, the freshwater pulse into the North Atlantic, would have triggered or amplified the thermohaline circulation shutdown responsible for the younger Dryas cooling. The hypothesis is not universally accepted. Several geologists and archaeologists have disputed elements of it. The interpretation of the nanodiamonds, the cosmic versus terrestrial origin of some of the spherules, the geographic extent of the impact markers. The debate in the technical literature is genuine and ongoing. Some critics argue that the markers can be explained by other mechanisms: volcanic activity, terrestrial wildfires, long-distance wind transport of micrometeorite material, or simple contamination between stratigraphic layers. The defenders of the hypothesis have responded to each objection with additional data. The nanodiamonds, they argue, are of a specific type, Lonsdaleite, that has not been reproduced by any known terrestrial process. The platinum anomaly is too widespread and too consistent to be volcanic in origin. Volcanic platinum signatures are chemically different from what is found at the younger Dryas boundary. The geographic distribution of impact markers, now spanning more than 50 sites across 4 continents, is difficult to explain by any single terrestrial mechanism. The balance of evidence, as of the most recent published analyses, favors the hypothesis over the alternatives, though the debate is not closed. What it means if the hypothesis is correct is this. Approximately 12,900 years ago, the Northern Hemisphere was struck by a distributed cosmic impact event of enormous energy. The resulting fires, cooling, and ecosystem disruption killed off most of the North American megafauna, devastated vegetation across temperate regions, triggered a 1,300-year climate catastrophe, and, importantly, struck precisely at the period when the archaeological record suggests humans were at their most complex and widespread in the Pleistocene. The Paleolithic world that existed immediately before the Younger Dryas was not a world of isolated hunter-gatherers stumbling through the wilderness. It was a world of sophisticated people with complex symbolic culture, long-distance trade networks, and, at a handful of specific sites, architectural ambition. The Younger Dryas event hit that world, and when the climate stabilized 11,600 years ago, the world that emerged, the world that went on to develop agriculture and build the first cities, was noticeably, measurably, genetically, and culturally different from the world before. Chapter 4. The Builders Who Came Before. In 1994, a Kurdish shepherd named Savak Yildiz was walking across a dry hillside in southeastern Turkey near the town of Şanlıurfa when he noticed something unusual sticking out of the ground. A carved piece of limestone, not a small carved piece. A massive T-shaped stone pillar buried in the soil, elaborately carved with animals, foxes, boars, cranes, wild ducks, in a style that combined technical sophistication with artistic ambition, unlike anything expected from the period it appeared to represent. The site was called Göbekli Tepe, the Hill of the Navel. And what archaeological excavation beginning in 1996 revealed, and what has been refined through nearly 30 years of subsequent work, has fundamentally changed what we thought we knew about the capabilities of Pleistocene humans. Göbekli Tepe contains at least 20 circular stone enclosures, constructed with T-shaped limestone pillars that weigh between 10 and 20 tons each. The pillars are elaborately carved with reliefs of animals, not just the food animals you might expect from hunter-gatherers, but complex symbolic representations, predators and birds, and serpents and abstract symbols, arranged with evident intentionality. The largest excavated enclosure has a diameter of about 30 meters. The two central pillars in each enclosure stand between 3 and 5 meters tall. The site was deliberately buried. Whoever built it, at some point, filled it in, covered the enclosures with rubble and debris, preserving them beneath the hill that accumulated above them over millennia. This preservation is what makes Göbekli Tepe so remarkable. The structures were not abandoned and left to decay. They were intentionally entombed. The radiocarbon dates from the site span roughly 11,500 to 8,000 years ago. The oldest layers predate the Younger Dryas boundary. The youngest post-date it. The site was in use and was being constructed before, during, and after the most severe climate disruption of the post-glacial period. The conventional archaeological story had held that large-scale architectural monuments were built by societies with agriculture, surplus food production, specialized labor, and organized social hierarchies. The sequence was agriculture first, then permanent settlement, then social complexity, then monumental architecture. Göbekli Tepe is the oldest known large-scale monumental architecture on Earth, and it was built, the best evidence suggests, by hunter-gatherers, by people who had not yet domesticated any crop plant, who were still hunting and foraging for their food, who were, in the conventional story, not supposed to be capable of organizing the labor required to quarry, transport, carve, and erect multi-ton stone pillars in precisely designed circular arrangements. Several possible responses to this evidence have been proposed. The first is that the site forced archaeologists to revise the conventional sequence. Maybe agriculture didn't come before monumental architecture. Maybe monumental architecture and the social complexity it requires came first, and agriculture was a consequence of settled communities rather than a precondition. The workers maintaining Göbekli Tepe needed feeding, and maintaining a large semi-permanent workforce around a ritual site might have provided the selective pressure that led to the domestication of local wild cereals. This is a real and interesting revision to the conventional story. It doesn't require anything unusual, it just requires adjusting the sequence of developments. The second response, the one that gets less academic airtime, but is harder to dismiss, is that Göbekli Tepe is the tip of something much larger, that the builders of these circular stone enclosures were not starting from scratch in 11,500 BCE, that they brought skills, knowledge, and social organization with them from somewhere else, and that the somewhere else was the pre-Younger Dryas world, the world that was partially destroyed by the catastrophe of 12,900 years ago, and which left no other archaeological record because it was built in places that are now underwater, or that were destroyed by the impact-related fires, or that have simply not been found. This second response requires taking seriously the following facts. Sea levels at the end of the last glacial maximum were approximately 120 meters lower than today. The continental shelves, the shallow underwater platforms extending from the coast, were dry land. The area of habitable land available to Pleistocene humans was substantially larger than the world we see on a modern map. The coastal zones, which are where most people have always lived because coastal ecosystems are the most productive, were not at today's coastlines. They were 120 meters of water below them. Any permanent settlements built on the Pleistocene coastlines, on the shores of the now submerged continental shelf, are now at the bottom of the sea, not metaphorically, literally. Drowned under 120 meters of water as sea levels rose during the post-glacial warming. The rate of sea level rise at various points in the post-glacial period was several meters per century, fast enough that settlements on gently sloping coastal plains would have been inundated within generations. Underwater archaeology, the search for submerged prehistoric sites, is in its infancy. The technology to conduct systematic survey of continental shelves at depths of 50 to 120 meters is expensive, difficult, and has been applied to only a tiny fraction of the total area available. What has been found in the limited areas surveyed is already extraordinary. Submerged stone structures have been identified off the coasts of India, the British Isles, the Mediterranean, and Japan. Lithic scatters, debris from stone tool manufacture, have been found on underwater banks off the coast of North America that were dry land during the last glacial period. The numbers here are worth dwelling on. The total area of continental shelf exposed during the glacial maximum, the land that was above water during the last ice age, but is now submerged, is approximately 27 million square kilometers. For context, the entire continent of Africa is about 30 million square kilometers. We have lost to the rising sea an area of habitable land approximately equal to the size of Africa. And that lost land was not interior land, it was coastal land. River deltas, estuaries, shallow bays, rich shorelines where fresh water meets salt water. The ecosystems that have always been most attractive to human settlement because they offer the greatest diversity of food resources. The coastal zones are where fisheries are richest, where transport is easiest, where trade networks most naturally develop, where the first permanent settlements have always tended to cluster. Every pre-Holocene coastal settlement on the continental shelf is now underwater, and we have surveyed at any depth of detail a fraction of a percent of that underwater terrain. What we have found in that fraction of a percent has already produced surprises. Off the western coast of India, at the Gulf of Combat, sonar surveys in 2001 identified a large area of apparently regular geometric structures on the seabed. Structures that, if artificial, would be consistent with a substantial settlement. The material is disputed. Some researchers argue it is natural geological formation, others that it represents human construction. And proper excavation has not been conducted. But the site lies on a continental shelf at a depth consistent with submergence during the late glacial period. In the North Sea, which during the glacial maximum was not a sea at all but an enormous plain called Doggerland, connecting Britain to continental Europe and supporting a thriving Mesolithic population. Artifacts have been dredged up by fishermen and occasionally by systematic archaeological surveys. Stone tools, animal bones, even fragments of worked wood have come up from the North Sea floor. Doggerland was populated, it was productive, and it was swallowed by the rising sea between roughly 10,000 and 6,000 years ago, forcing its inhabitants to move onto higher ground and fundamentally reshaping the human geography of Northern Europe. The absence of Pleistocene coastal civilization from the archaeological record is not evidence that it didn't exist. It is evidence that we have not yet looked in the right places. And the right places are currently under water. Chapter 5. The pattern of collapse. Let me change the scale for a moment, and instead of reaching back 12,000 years, look at the much better documented history of the past 5,000 years, because here is something that the conventional narrative of human civilizational progress consistently underemphasizes. Civilizational collapse is not rare. It is the norm. Complex societies do not last. They rise, reach a peak of connectivity and complexity, and then fall, sometimes gradually, sometimes with extraordinary suddenness, leaving behind only the monuments, the cultural memories, and the genetic traces that survived the disruption. The Bronze Age collapse of roughly 1200 BCE is one of the best documented examples. In the space of about 50 years, every major palace civilization in the Eastern Mediterranean was destroyed. The Hittite Empire, which at its peak controlled most of Anatolia and had fought Egypt to a standstill, collapsed so completely that it vanished from the historical record for 3,000 years. The Mycenaean Greeks, the civilization of Agamemnon and Achilles, the people who built the Palace of Knossos and the Lion Gate at Mycenae, collapsed, and their writing system, Linear B, was lost with them. The palace cities of the Levantine coast, Ugarit, Hazor, Megiddo, were destroyed and abandoned. Egypt survived but was severely weakened, never again to exert the dominance it had enjoyed at the height of the new kingdom. The population of the eastern Mediterranean fell by an estimated 20 to 50% in the space of a century. Some regions that had supported urban populations for thousands of years went largely uninhabited for centuries. Writing in much of the affected area disappeared. Trade networks that had connected the entire Mediterranean basin ceased to function. The record goes dark. We know about the Bronze Age collapse because we have written records from just before it, diplomatic correspondence, trade documents, and a small number of texts from survivors describing the catastrophe in terms of fire, invasions, famine, and the appearance of the mysterious sea peoples. But we do not fully understand its causes even today, with all those records. The best current hypothesis involves multiple simultaneous stresses: a prolonged drought, systems disruption in the complex trade networks that Bronze Age civilizations depended on, political instability, and possibly waves of displaced peoples from other areas where these stresses had already caused collapse. The knowledge that was lost in the Bronze Age collapse is worth cataloging because it illuminates what a reset actually means in practical terms. The Mycenaeans knew how to produce purple dye from murex shellfish, an extraordinarily labor-intensive and technically complex process that produced the famous Tyrian purple that would later become the color of Roman emperors. After the collapse, purple dye production disappeared from the archaeological record for centuries before being rediscovered. They knew how to construct multi-story dressed stone buildings with advanced drainage systems. This architectural knowledge had to be partially reinvented by the later Greeks, who built their early temples in wood before eventually returning to stone. They maintained specialized palace economies with detailed accounting systems. The Linear B tablets record thousands of individual transactions involving textiles, livestock, spices, metals, and labor allocations. All of that administrative knowledge and all of the specialized professional roles it supported was gone within a generation or two. This is what collapse looks like in a society where we have the documents to track it. We can watch in the surviving archive of letters from Ugarit in the final years before its destruction as the trading networks unravel, as requests for grain go unanswered, as desperate messages from coastal cities report that the sea is being watched for ships that are no longer coming. We can read the last letter ever sent from Ugarit to the king of Alashia, asking for help against attackers who have burned cities and harvests. A letter found in the kiln still being fired when the city was destroyed and never sent. We have that kind of documentary record because Bronze Age civilizations had writing. Societies without writing leave no such record. Their collapse is visible only in what ceases to appear in the archaeological record. The end of a pottery style, the abandonment of a site, the genetic discontinuity in ancient DNA. And the society that existed before the Younger Dryas if it was more complex than we currently credit, left no writing that has survived, and no structures except those deliberately buried on high ground. The point for this video is not the specifics of the Bronze Age collapse. The point is what it demonstrates about the fragility of complex civilizations. The Mycenaean Greeks wrote a complex administrative script, Linear B, that they used to manage palace economies involving thousands of individual transactions. They built multi-story stone palaces with sophisticated drainage systems. They maintained trade networks spanning the entire Mediterranean. They were, by any reasonable definition, civilized. And within a century, it was gone. Not just weakened or reduced, gone. Linear B vanished so completely that where it was deciphered in 1953 by Michael Ventris, it was after 3 millennia of nobody on Earth being able to read it. The Greek-speaking world that came after the Bronze Age collapse, the world that produced Homer and Sophocles and Plato, had entirely lost the memory of its own immediate predecessor civilization. The Iliad was not written during or after the Mycenaean civilization. It was composed by people who had only oral tradition and legend connecting them to a world that had existed a few centuries earlier, a world that left physical ruins but no readable texts. If the Bronze Age collapse could erase the memory of an entire literate civilization within a few centuries, what could a larger, more geographically widespread catastrophe do to a less literate world? What could the younger Dryas impact, if the hypothesis is correct, do to a globally distributed culture of hunter-gatherers and early complex societies whose technology was made of organic materials that decay, whose settlements were on coastal plains now underwater, and whose accumulated knowledge was transmitted primarily through spoken language and memory rather than written records? The answer, almost certainly, is that it could leave almost nothing. A few scattered monuments in elevated inland areas, preserved by deliberate burial. A degraded oral tradition that would, over 10 or 15,000 years, become mythology. A genetic signal in the genome partially overwritten by subsequent population movements. And a handful of anomalous archaeological sites that don't fit the model. Which brings us back to Göbekli Tepe, and to a broader pattern that is visible across the archaeology of the immediately post-Younger Dryas period, if you know where to look. Göbekli Tepe is not unique. It is simply the most dramatic and best preserved example of a group of sites that share certain characteristics: monumental stone construction, circular or enclosed architectural arrangements, elaborate animal symbolism, and dating to the period between roughly 12,000 and 9,000 years ago, the period immediately following the Younger Dryas, when the climate was stabilizing and human populations were beginning to rebuild. Karahan Tepe, also in southeastern Turkey, is a site that archaeologists have been describing as Göbekli Tepe's sister site since major excavations began in 2019. It is larger than Göbekli Tepe. It is in some respects even more sophisticated. Its sculptures include a lifelike human head carved in the round, with a level of artistic realism that in the conventional sequence should not exist at 11,000 BCE, and a series of phallic pillars arranged around a central carved figure that suggest a complex symbolic or ritual program. Karahan Tepe, Taş Tepeler, Tsayonu, Neveli Sori. These are all sites in the same region of southeastern Turkey, all dating to the same post-Younger Dryas window, displaying levels of architectural and artistic sophistication that the conventional model cannot cleanly explain. They are not individually proof of a prior civilization, but collectively, they are evidence that the people of 11,000 BCE were not starting from zero. They were working with skills, knowledge, and symbolic vocabularies that had been developed over a long preceding period. A preceding period whose direct physical record has mostly not survived. Notice something that is rarely emphasized in discussions of these sites. Göbekli Tepe and its sister sites are all located in a specific geographic region, the Piedmont zone of the Taurus and Zagros mountain ranges, at elevations between 700 and 900 meters above sea level. They are not on the coastal plains that were the prime habitation zones during the Pleistocene. They are in the highlands, in areas that were less productive, less comfortable, but crucially, above the rising sea. If the builders of these sites had come from lowland or coastal communities that were being swallowed by the rising waters, they would have retreated uphill. They would have built their monuments on high ground. They would have done exactly what the archaeology shows. The question that all of this raises, the question that is the title of this video, is whether that preceding period included something that qualifies as civilization. Not necessarily in the modern sense, not necessarily cities, or writing or metalworking, but perhaps something in the sense that matters most: accumulated, transmissible, culturally complex knowledge about how to organize groups of people, how to manage resources, how to construct the social technologies that make cooperation possible at scale. If that knowledge existed before the Younger Dryas, and if the Younger Dryas impact reduced the population of the relevant regions by a significant fraction and disrupted the transmission of that knowledge, then what we call the birth of civilization around 10,000 BCE is not a birth. It is a recovery, a reconstruction from partial memory and surviving expertise in a world that had been catastrophically simplified. Chapter 6: The Mathematics of Collapse. Why civilizations are fragile by design. There is a common assumption about civilizational collapse that is almost universally held and almost universally wrong. The assumption is that collapse requires an external cause, that something must happen to a civilization to bring it down: a climate catastrophe, a military conquest, a pandemic, a volcanic eruption. That in the absence of such an external shock, a complex society is stable, self-sustaining, durable. This assumption is wrong, and understanding why it is wrong is essential to understanding why civilizational resets are not just possible, but in a deep mathematical sense, inevitable. The field of complexity theory, the branch of systems science that studies how complex adaptive systems behave, has, over the past 3 decades, produced a body of results that are directly relevant to the history of human civilizations. The relevant finding can be stated simply: complexity in a system tends to grow until it becomes fragile, and fragile systems collapse under stresses that would not have troubled them when they were simpler. The mechanism is this: complex societies solve problems by adding complexity. When a society faces a resource shortage, it develops more sophisticated resource extraction methods. When it faces administrative challenges, it adds more administrative layers. When it faces security threats, It builds larger armies and more elaborate fortifications, which require more resources, which require more administrative complexity to manage. Each problem-solution cycle adds a layer of interdependency. Each layer of interdependency is a potential failure point. The archaeologist Joseph Tainter developed this model most rigorously in his 1988 book, The Collapse of Complex Societies. Tainter's thesis is that collapse is not a failure of civilization, but a rational response to diminishing returns on complexity. At a certain level of complexity, the marginal benefit of adding another layer of organization or technology falls below the marginal cost. The society has grown complex enough that its complexity is consuming more resources than it produces. At that point, simplification, what we call collapse, is actually the efficient solution. Resources flow to simpler, less costly forms of organization. This framework makes a specific prediction that is relevant to the reset hypothesis. The most sophisticated, most complex societies are the most fragile. They are the most vulnerable to collapse because they have the most interdependencies, the most specialized roles, the most brittle supply chains, and the most extensive infrastructure that requires continuous maintenance. A society operating at the frontier of its complexity, which is, almost by definition, the most advanced society, is operating at its maximum fragility. Now, apply this to the Pleistocene world. If, and this is the central speculative claim of this video, there existed in the period before the Younger Dryas a level of human social complexity substantially greater than the conventional model credits, then that complexity was, by Tainter's logic, fragile. Not fragile in the way a house of cards is fragile, where any breath of air will knock it over. Fragile in the way a finely tuned machine is fragile. Robust against normal operating conditions, catastrophically vulnerable to conditions outside its design parameters. To make this concrete, think about what the late Roman Empire actually looked like in the decades before its collapse. The Western Empire in the 4th and 5th centuries was not a society in obvious crisis. It had roads that functioned, cities with populations of hundreds of thousands, a legal system of extraordinary sophistication, military, forces equipped with the best weapons of the age, and a bureaucracy capable of coordinating activity across an area spanning from Britain to the Middle East. It was enormously complex, and its complexity was precisely what made it fragile. The Roman army required constant financial support from taxation. The taxation system required a functioning provincial administrative apparatus. The provincial apparatus required literate administrators who required schooling in Latin and Roman law. The schooling required stable cities. The stable cities required grain imports from North Africa. The grain imports required a functioning Mediterranean naval network. The naval network required timber from increasingly distant forests. The timber supply required overland road networks maintained by corvée labor. The corvée labor required a functioning land tenure system that was being steadily undermined by the same fiscal pressures the empire was trying to address by expanding the tax base. Each element of this system was dependent on every other element. Pull out any single link, stop the North African grain, disrupt the naval networks, collapse the provincial tax collection. And the cascade of failures that followed was not manageable by patching the specific failure. It was systemic. It could only be arrested by simplification, by shedding the elements of the system that cost more in resources than they produced in stability. That is what happened. The Western Roman Empire simplified. The cities lost population. The roads stopped being maintained. The administrative class shrank. The legal system became locally variable. The long-distance trade networks contracted. Within 2 centuries of the formal end of the Western Empire, in 476 CE, the population of Rome had fallen from roughly 1 million to perhaps 30,000. The aqueducts that had brought clean water to that 1 million people still stood but were no longer being maintained. The knowledge of how to maintain them, not the physical knowledge of the aqueducts themselves, but the social and institutional knowledge of the engineer class, the water board, the maintenance contracts, the budget allocation, was gone. Not because anyone had forgotten it in an individual sense, but because the social structure that organized and applied that knowledge had dissolved. The Younger Dryas event, a rapid temperature drop of 15 degrees in the North Atlantic, a 1,000-year climate disruption, a possible cosmic impact with regional firestorms across North America, is not a normal operating condition for any human society. It is the kind of multi-layered, simultaneous catastrophe that takes a complex, brittle system and destroys it in ways that a simpler system would survive. A band of foragers living on generalist skills and stored knowledge about their local environment can survive a century of climate disruption by moving, by changing their food sources, by falling back on a broad repertoire of adaptive strategies. Their lifestyle requires no specialized infrastructure, no supply chains, no administrative hierarchy, no stored agricultural surplus that can be destroyed in a bad harvest. A more complex society, one with agricultural surpluses that can fail, with a specialized labor force that cannot easily switch roles, with a geographic footprint that includes low-lying coastal settlements now being inundated by the sea, with a social organization that requires the continuous function of administrative and ritual roles, is far more vulnerable. The same century of climate disruption that a forager band rides out as a difficult period would, for a complex society, represent a cascade of interlocking failures. Harvest failure leading to social instability leading to administrative breakdown leading to the loss of the knowledge required to maintain complex technology, loss of technology leading to resource collapse. Within 2 or 3 generations, the knowledge is gone. The social structures that transmitted it are gone. The infrastructure is gone. What survives is simplified, a remnant population with memories of a more complex world that they can no longer maintain, slowly rebuilding in a changed environment. This is not a hypothesis unique to prehistory. We have watched this process happen in slower motion in the historical record. The fall of the Western Roman Empire reduced the population of Rome from 1 million at its peak to perhaps 20,000 within a century. The engineering knowledge required to build Roman aqueducts, some of which functioned for centuries without significant maintenance, was not written down in a form that survived the collapse. Medieval Europeans looked at Roman ruins and thought they had been built by giants, because the social and technical organization required to build them was no longer legible. If Roman engineering knowledge could become incomprehensible to Europeans within a few centuries, the knowledge of a pre-Younger Dryas society could become entirely invisible, literally and figuratively, within the 12,000 years that separate us from that event. Chapter 7: The Memory Problem. What actually survives a reset? When a complex society collapses, three things survive with any reliability: physical structures that are large enough and durable enough to outlast the collapse, genetic information encoded in the DNA of the survivors, and oral tradition, story, the most ancient and most resilient information storage medium humans have ever developed. Let's examine each of these, because the specific character of what survives tells us something important about what might have been lost. Physical structures. Stone survives. Not all stone, not in all conditions. Limestone dissolves slowly in rain, sandstone erodes, even granite weathers over geological time. But stone in sheltered conditions, particularly stone that is buried and protected from surface weathering, can last essentially indefinitely. Göbekli Tepe's preservation is due almost entirely to the fact that it was deliberately buried. The burial that its builders performed 8,000 or so years ago protected it from the weathering that has destroyed virtually every other surface structure of comparable age. What stone does not preserve is the meaning of what it depicts. Göbekli Tepe's pillar reliefs, the foxes, the boars, the cranes, the scorpions, the vultures, clearly carry symbolic content. The arrangements are not random. The specific animals, the specific combinations, the specific geometric elements that appear alongside them. These are a message in a language we cannot read, from a culture whose cosmology, mythology, and belief system are entirely opaque to us. We have the stone. We have lost everything it was trying to say. This is the specific tragedy of a pre-literate reset. Writing encodes meaning in a recoverable form. Stone encodes form without meaning. The builders of Göbekli Tepe clearly had meaning. They were transmitting something through the architecture and the imagery. But without a Rosetta Stone for their symbolic system, we are left with the shape of the message and none of its content. Wood does not survive. Textile does not survive. Organic compounds, the vast majority of every object that ancient humans produced, do not survive. What we recover from the deep archaeological record is the tiny, anomalous fraction of what existed that happened to be made of imperishable material and happened to be preserved in conditions that prevented its destruction. For every stone tool in a museum, there were hundreds of wooden handles, leather bags, woven baskets, and cordage that held the tool in use, all gone. For every carved ivory figurine, there were hundreds of carved wooden counterparts, all gone. The physical record of the past is not a fair sample of what existed. It is an extreme selection biased toward the indestructible and against the organic. Any civilization whose technology was based primarily on organic materials, wood, fiber, leather, bone, is essentially invisible in the archaeological record, no matter how sophisticated it was. A society that built in wood, no matter how elaborate, leaves no more trace than the post holes of its vanished buildings. Genetic memory. DNA survives better than wood, but less well than stone. Ancient DNA degrades in heat and humidity, but can persist for tens of thousands of years in cold, dry conditions, which is why our ancient DNA record is biased toward cold climates and recent periods. The genomes of ancient Europeans, some going back 45,000 years, can be sequenced from teeth and bones. the genomes of ancient inhabitants of tropical Africa and Southeast Asia, even from just 10,000 years ago, are largely unrecoverable because the climate destroys the DNA faster. What DNA tells us, as we discussed in Chapter 2, is population history, births, deaths, migrations, admixtures, and bottlenecks. It tells us who was where and when. It tells us about population sizes. It tells us about relationships between groups. It tells us about selection, which genes increased in frequency over time, suggesting that the traits they encode were advantageous in particular environments. What DNA cannot tell us is anything about culture, technology, knowledge, or belief. The genome does not encode civilization. Two populations can be genetically nearly identical and have utterly different cultures. The ancient DNA that shows us the Upper Paleolithic European population largely disappearing and being replaced after the glacial maximum tells us about the people, but nothing about what they knew. The knowledge encoded in those disappeared people, their cosmologies, their engineering techniques, their oral traditions, their understanding of the natural world, died with them. Or rather, died with their culture, since some of their genes persist in modern Europeans in small proportions. Oral tradition. This is the most interesting survival mechanism and the most underappreciated by the scientific community. Oral traditions can preserve specific factual information across extraordinarily long periods of time. In 2015, a study published in the journal Quaternary Science Reviews examined Aboriginal Australian oral traditions about coastal geography and sea level change. The traditions described specific bays, headlands, islands, and coastal features that the researchers were able to correlate with the bathymetric underwater topography record of the continental shelf. Some of the described features, now submerged under 30 to 60 meters of water, had been above sea level between 7,000 and 12,000 years ago. The Aboriginal traditions were preserving specific, accurate geographical information across a minimum of 7,000 years, and potentially 12,000 years of oral transmission, not metaphorical coastlines, not symbolic water, specific features of specific places now underwater, described accurately in stories maintained by communities who had never seen the original features, transmitted by word of mouth across hundreds of generations. The research team, led by Patrick Nunn and Nicholas Reed, was not looking for evidence of accurate oral tradition when they began the study. They were looking at Aboriginal Australian stories about the coast for anthropological purposes and noticed, almost incidentally, that some of the stories described features of the seafloor, islands, headlands, reefs, that were now underwater. They checked the geological record. The features were there at the described locations, at the depths consistent with submergence at the times indicated by the stories. The match was not approximate. It was specific enough that the researchers concluded the stories were genuine, transmitted memories of a coastline that had not existed above water for thousands of years. The implications were profound. If oral tradition can preserve specific, verifiable geographical information for 10,000 years, then the information content of global mythology is not the primitive, unreliable folk memory that the academic mainstream has often treated it as. It is a compressed, robust, extensively field-tested archive of human experience across deep time. The medium, story, is not inferior to writing. It is different from writing, and for some purposes, the transmission of emotionally salient, culturally important information across pre-literate societies, it is arguably superior. A story that is told around fires for 10,000 years, refined by generations of storytellers who notice when the telling is unclear or the details are wrong, is a remarkably robust information carrier. This result fundamentally changed what we thought oral tradition could do. If a small, non-literate culture can preserve precise geographical information for 10,000 years of oral transmission, the information content of global myth traditions, the flood stories, the star lore, the cosmological narratives, is not the naive, unreliable folk memory that the academic mainstream has long assumed. It may be a compressed archive of real historical events, encoded in story form specifically because story is robust, memorable, and transmissible in ways that technical documents are not. This has a specific implication for the reset hypothesis. If the people who survived the Younger Dryas event encoded what they knew about the catastrophe, about the world that had existed before, about the technical and social knowledge of their predecessors, in story and ritual and myth, and if those stories were transmitted orally across the following millennia, some fraction of that knowledge would have survived into the literate period. It would have survived in degraded form, stripped of its technical content, mythologized beyond easy recognition but structurally present. The flood myths are the most obvious candidate, but there are others. The widespread mythological motif of a golden age, a previous, more perfect world that was destroyed and lost, appears in Greek mythology, the age of Kronos, in Hindu tradition, the Satya Yuga, in Norse tradition, the world before Ragnarok, in Aztec tradition, the previous 4 suns. These traditions, from cultures with no historical contact, all describe a world before the present one that was more perfect, more abundant, and that was catastrophically destroyed. The present world is a diminished successor to something greater. This is a remarkable and specific motif to find distributed globally. It is not a random mythological theme. It is the memory, preserved in the only available medium, of a world that was better than the one the storytellers inhabited, a world that was lost to catastrophe. Chapter 8. The Fermi Paradox Angle, Civilizations That Reset Themselves into Silence. Here is where the reset hypothesis connects to a question that seems entirely different but turns out to share the same deep structure. The Fermi Paradox. You may know it. If the galaxy is as old as it is, 13 billion years, and if life and intelligence arise on the timescales, and with the frequency that our existence suggests they should, then the galaxy should be full of civilizations, many of them billions of years older than ours. And yet we see no evidence of any of them. No signals, no megastructures, no colonization of the galaxy. The sky is quiet. Where is everyone? Dozens of proposed resolutions to the Fermi paradox exist. Life is much rarer than we think. Intelligence is much rarer than we think. The distances are too vast for any civilization to bridge. Advanced civilizations destroy themselves before reaching interstellar capability. Advanced civilizations choose to be undetectable. Advanced civilizations transcend physical existence. The reset hypothesis offers a specific and underappreciated resolution to the Fermi paradox, one that doesn't require any of these speculative mechanisms. What if civilizations don't typically reach the interstellar stage? Not because they self-destruct in the science fiction sense. Not because they build nuclear weapons and blow themselves up, but because they cycle. They rise, reach a certain level of complexity, hit a natural or self-generated catastrophe at the threshold of their fragility, collapse back toward simplicity, and begin rebuilding. Over and over. The cycle repeats, potentially indefinitely, on a timescale of thousands to tens of thousands of years per cycle. In this model, a civilization never accumulates the sustained, uninterrupted technological development needed to achieve interstellar capability. Not because any one catastrophe destroys it permanently, but because each reset destroys enough accumulated knowledge and infrastructure that the species must spend thousands of years in recovery before approaching the technological frontier again. And then another catastrophe hits, and another recovery begins. The human evidence, as laid out in this video, is consistent with at least one such reset, possibly more. The geological record suggests the Earth's recent history has been punctuated by multiple climate catastrophes, impact events, and volcanic episodes severe enough to qualify as civilization-ending stresses. The Toba eruption 74,000 years ago. The Lasher Sea eruption in Europe around 13,000 years ago. The Younger Dryas event at 12,900 years ago. The 8.2 kilo-year event at 8,200 years ago. The Bronze Age collapse at 1,200 BCE. Some of these affected entire hemispheres. All of them struck civilizations at various stages of development and forced them back towards simpler forms. If this is the characteristic trajectory of technological civilization, growth, increasing fragility, catastrophe, reset, regrowth, then the Fermi paradox is not primarily a question about intelligence or distance or intent. It is a question about whether any civilization has ever managed to reach the technological capability for interstellar expansion before the next reset hit. The critical threshold is not intelligence. It is continuity, sustained, uninterrupted technological progress for long enough to develop the specific capabilities, energy generation, materials, science, propulsion, physics, long-duration life support, needed for interstellar travel or communication at detectable scales. The human species has been in its current period of uninterrupted technological development for roughly 500 years since the scientific revolution. We are nowhere near interstellar capability. We would need several more centuries of uninterrupted development at our current pace, at minimum, before becoming visible to a galactic observer. 500 years is nothing on the scale of civilizational cycles. The Bronze Age collapse set back the Eastern Mediterranean by several centuries. The fall of Rome set back European technological development by up to 1,000 years in some domains. A reset comparable to the Younger Dryas impact, affecting not one region, but the entire Northern Hemisphere simultaneously, would potentially set back global civilizational development by thousands of years. To make this concrete, consider the counterfactual. Imagine that the Younger Dryas impact had not occurred. Imagine that whatever level of social complexity existed before 12,900 years ago had been allowed to continue developing uninterrupted for the 12,900 years that have since passed. Human technological progress is not linear. It accelerates as each new tool becomes available to build the next tool. The time from the invention of writing to the printing press was about 5,000 years. The time from the printing press to the first computer was about 500 years. The time from the first computer to artificial intelligence was about 70 years. The pace of development roughly doubles with each fundamental transition. A civilization that avoided a major reset 12,900 years ago and developed at even a fraction of the rate we have managed in the past 500 years would, today, be so far beyond our current capabilities that we would not recognize them as the same species. Not because they would be biologically different, because 12,900 years of uninterrupted compounding technological development, starting from wherever the pre-Younger Dryas world was, is an incomprehensible head start. That civilization would be the ones the Fermi paradox asks about, the ones we don't hear from. Maybe they're not out there because they don't exist. Or maybe they reset, just like us, before they got far enough. And maybe they're cycling through the same pattern we appear to be cycling through right now, in this very chapter of the story. If such resets happen, on average, every 10,000 to 15,000 years, which is broadly consistent with the catastrophic events in Earth's recent geological record, then the probability of any given civilization making it past the 10,000-year uninterrupted development threshold before the next reset is very low. Not zero, but low enough that, multiplied across the billions of potentially inhabited worlds in the galaxy, the expected number of civilizations that have successfully escaped the reset cycle and achieved interstellar visibility could be very small. This is not a comforting resolution to the Fermi paradox. It does not reassure us that civilizations are rare and we are special. It suggests the opposite, that civilizations are common, but that the universe is a place where complexity tends to be knocked back before it can propagate beyond its home world. A cosmic pattern of growth and reset, repeated across billions of worlds, producing a galaxy full of civilizations that never quite make it out. The silence of the sky in this reading is not the silence of an empty universe. It is the silence of a universe full of civilizations that keep getting interrupted. Chapter 9. What would survive? If it happened again, let's make the question personal, specific, concrete. We are, right now, living through the most complex and most fragile period in human civilizational history. The global economy is a network of interdependencies so intricate that a shipping disruption in the Suez Canal slows car production in Germany. The food supply of industrialized nations depends on just-in-time logistics chains that would fail within weeks without continuous functioning of port infrastructure, fuel supply, and refrigeration. The technical knowledge required to maintain the global electricity grid is held by a relatively small number of specialized engineers and is not, in any meaningful sense, written down in a form that a post-collapse society could use without significant pre-existing expertise. We are more complex and therefore more fragile than any civilization that has ever existed. And we live on a planet whose geological and astronomical history includes multiple events capable of destabilizing or destroying civilizations less complex than ours. What would survive if we experienced right now a civilizational reset comparable to the Younger Dryas event? This is not a hypothetical designed to be alarmist. It is a diagnostic question. Understanding what would survive and what would be lost is how you understand what a reset actually costs and what we might do if we cared about the continuity of our accumulated knowledge to improve the odds of something meaningful making it through. Physical infrastructure. The most durable physical structures we have built are, paradoxically, not the most important ones. The nuclear power plants and data centers and telecommunications infrastructure that underpin modern civilization are extraordinarily fragile without continuous maintenance, fuel supply, and specialized expertise. Within years of a collapse of industrial supply chains, most of this infrastructure would become non-functional and then dangerous. The Chernobyl exclusion zone is a preview of what happens to complex technical infrastructure when human maintenance stops. What would survive physically is largely what is built from stone and concrete. Roads, dams, the concrete foundations of buildings, in a form that outlasts the functions they were built to serve, providing evidence to future archaeologists that a complex civilization existed, but not much information about what that civilization knew or could do. The same situation, broadly, as the Roman aqueducts today. Think about what the physical signature of our civilization would look like to an archaeologist 12,000 years from now. The same distance that separates us from Göbekli Tepe. The concrete infrastructure would be present as rubble. The specific chemical signature of industrial pollution, elevated lead, carbon isotope, ratios, microplastics, would appear as a distinct stratigraphic layer in sediments and ice cores, just as the Younger Dryas impact layer appears today. The nuclear testing we conducted in the 1950s and 60s left a spike of radioactive isotopes, specifically carbon-14 and cesium-137, that will remain detectable in the geological record for thousands of years. Future geologists will date our era by the radiocarbon bomb pulse, just as we date organic material from our era by that same spike. Those future geologists would know a complex civilization existed. The pollution layer, the isotope anomalies, the microplastic deposits in ocean sediments, the massive landscape modifications of agriculture and urbanization, all visible in the stratigraphy. They would know from the isotope chemistry that this civilization had achieved nuclear technology. They would find in the ruins of our cities the geometric regularity of planned street grids. They would find our stone and concrete structures stripped of everything organic and metallic, producing plans that would tell them about the scale of our settlements, but nothing about our literature, our science, our music, or our understanding of the cosmos. They might find, if they were lucky, a few titanium spacecraft on the Moon or Mars, more durable than anything on Earth, preserved in vacuum. Those spacecraft would tell them we had achieved space travel. Combined with the nuclear isotope signature, they would conclude we were technologically sophisticated. They would not know what we knew. They would not be able to read this script. That is the physical legacy of our civilization to a post-reset world, impressive in outline, empty of content. Books would survive in archives, in the short term, decades to perhaps a century. Paper is more durable than is commonly assumed. Paper books from the 15th century are still perfectly readable today. But without the maintenance of the buildings that store them, without climate control, without active conservation, books accumulate moisture, develop mold, and degrade within a century under most conditions. The world's written knowledge, including, critically, the technical knowledge required to rebuild industrial civilization, is stored primarily in formats, digital, that require continuous active infrastructure to remain accessible, and secondarily in formats, paper, that would largely fail within a century of infrastructure collapse. A civilizational reset comparable to the Younger Dryas would leave, within a century, very little of our accumulated technical knowledge in readable form. The knowledge of how to make silicon chips, how to refine uranium, how to build a jet engine, how to synthesize pharmaceuticals. This knowledge exists primarily in living experts, in digital databases requiring active infrastructure, and in technical documents that require functioning industrial civilization to produce the prerequisites for understanding. It is not indestructible. It is, in fact, extraordinarily fragile. What would persist? What would survive reliably across a genuine civilizational reset is more limited but more durable than most people imagine. The simplest and most robust technologies, the ones that require the least specialized infrastructure and the most generally transmissible knowledge, would survive in practice. Agriculture, in its basic forms, requires only seeds, soil, water, and the knowledge of when to plant and harvest. That knowledge is robust. Billions of people alive today possess it. It would not be lost. Fire-making, basic metallurgy in its simplest forms, smelting iron from surface ores, textile production, the construction of basic earthwork and timber structures. These are technologies with shallow knowledge requirements, widely distributed expertise, and long track records of surviving civilizational disruptions. They survived the Bronze Age collapse. They survived the fall of Rome. They would survive a much more severe reset carried in the minds and hands of the farmers and craftspeople who practice them. What gets lost is the upper layer, the knowledge that sits at the top of long chains of prerequisite knowledge that requires generations of specialized education to produce even a single practitioner, that is held by relatively small numbers of people at any given time. The knowledge of how to synthesize antibiotics, which requires organic chemistry, which requires laboratory equipment, which requires precision manufacturing, which requires metallurgy beyond what a pre-industrial society can manage. The knowledge of how to sequence a genome, the knowledge of how to predict the trajectory of an incoming asteroid, the knowledge of how to build a satellite. None of this is recoverable quickly. None of it is written down in a form that a post-reset society could use without the industrial and educational infrastructure to make use of it. Knowledge exists, technically, in the libraries that would survive the first century of a reset, but knowing that antibiotics exist, even knowing their chemical structure, is worthless without the manufacturing chain to produce them. The map is not the territory. The knowledge document is not the knowledge. There is a project initiated by the Long Now Foundation called the Rosetta Project, an archive of human languages on nickel discs designed to be readable with a 10 times optical magnifier for the next 10,000 years without any technology. The Long Now Foundation explicitly framed this project around the possibility of civilizational disruption, around the question of what we would want future humans to be able to read if the infrastructure required for digital access no longer existed. It is a small project. It covers languages. It does not cover chemistry, or physics, or medicine, or agriculture, or engineering. But it is the right kind of thinking. The question of what to preserve for continuity, in what format, at what level of redundancy and geographic distribution, against what threat model. This is a question that we have the knowledge to answer and have barely begun to ask. The scientific knowledge encoded in physical constants and natural phenomena would survive, in a sense, as the world that a post-reset civilization would eventually rediscover. The laws of thermodynamics are not stored in books. They are expressed in the behavior of steam and heat and work. A post-reset civilization would rediscover them, as we discovered them, by building things and noticing how they behave. The speed of light is not stored in a database. It is a property of photons. Mathematics would be reinvented, slowly, painfully, incompletely at first, but eventually fully, by minds as capable as ours working on the same problems we worked on. What would be lost is not the underlying reality of the physical world, which is indestructible. What would be lost is the centuries of accumulated work it took to discover that reality. The false starts, the discarded theories, the gradually refined measurements, the institutional structures that enable large-scale scientific collaboration. The loss would not be permanent in the sense that a sufficiently long-lived post-reset civilization would eventually rediscover everything we know. But it would represent thousands of years of delay, thousands of years during which the knowledge existed, encoded in the world, but not yet re-extracted by the minds capable of reading it. This is what a reset costs, not the destruction of reality, the destruction of our access to our understanding of reality, the burning of the library, not the loss of the book's subjects, but the loss of the books. And this brings us to the most important question this video can ask. Conclusion. The obligation of the ones who know. If you have followed this video to its end, you now understand something that most people do not think about, even though it is arguably the most important empirical context for human civilization. We are probably not the first. Not in the strong sense. Not, there was an advanced technological civilization before ours that built cities and invented computers. The evidence does not support that claim, and it is not the claim this video has made. In the more precise, more defensible, and more unsettling sense, the record of human prehistory contains evidence of at least one catastrophic disruption, the Younger Dryas event of 12,900 years ago, that was large enough, sudden enough, and broad enough to have destroyed whatever level of social complexity then existed and sent the survivors back toward simpler forms of organization. The genetic record shows population discontinuities in the relevant period that have not been fully explained. The archaeological record shows, immediately after that event, a level of architectural and artistic sophistication at sites like Göbekli Tepe that the conventional model cannot cleanly account for. The mythological record of every major culture preserves stories of a world that was destroyed and a world rebuilt from its ruins. The cumulative weight of this evidence is not proof. It is not conclusive. There are alternative explanations for each individual piece, and the mainstream of academic archaeology remains, for the most part, unconvinced that anything beyond the conventional story is required. But the cumulative weight is real, and the possibility it points toward, that human civilizational development has been interrupted at least once, possibly more than once, and that we are living in the recovery, has implications that extend well beyond academic archaeology. The most important implication is about fragility. If our civilization is not the first to have reached a significant level of complexity, and if previous civilizations were destroyed by the kinds of events that the geological record shows have occurred repeatedly in the Earth's recent history, cosmic impacts, supervolcanic eruptions, rapid climate shifts, then the possibility of those events occurring again is not a distant abstract risk. It is a historical pattern, one with a recurrence rate. The Younger Dryas impact hypothesis, if correct, implies that a major comet fragmentation event struck the Earth 12,900 years ago. The Taurid meteor stream, the debris field associated with the breakup of a large comet that is the probable source of the Younger Dryas impactors, is still there. The Earth still passes through it twice a year. The probability of a future impact from this source is not zero. It is not calculable with precision, but it is not zero. Supervolcanic eruptions, of the scale that produced the Toba eruption or the Lasher Sea event, happen on geological timescales that, from the perspective of human civilization, feel like they could happen at any time. The Yellowstone caldera, the Campi, Flegrei supervolcano in Italy, the Taupo system in New Zealand. These are not extinct. They are sleeping. The geological record of their eruptive histories suggests recurrence intervals of tens of thousands to hundreds of thousands of years. We are not overdue for all of them. We may be overdue for some. Rapid climate shifts, of the kind that produced the Younger Dryas, are not confined to the deep past. The thermohaline circulation that was disrupted 12,900 years ago is, by many oceanographic measurements, showing signs of weakening today. Whether the current trajectory represents a natural oscillation or the beginning of a tipping point is one of the most actively debated questions in climate science. The answer matters enormously, not only for the generations alive now, but for the continuity of the civilizational project that those generations are part of. The pattern of human civilizational history, read through the lens of the evidence we have examined in this video, is not a story of smooth, inevitable progress from caves to cities to stars. It is a story of growth and catastrophe, complexity and reset, knowledge accumulated and knowledge lost. A story that may have been running for far longer than we acknowledge, with chapters we cannot read because they are at the bottom of the sea, or encoded in myths we have not yet learned to translate. That story has not ended. We are in one of its chapters, somewhere in the middle, not at the conclusion. The question this video has been building toward is not really about the past. It is about the present and the future. If we accept, even tentatively, the possibility that complex human civilizations have been reset before, that the knowledge we have accumulated is not the first accumulation, and that the events capable of ending it have happened before and will happen again, then the response to that possibility is not despair. It is a specific practical obligation. The obligation to preserve. Not to preserve in the current form. Not to freeze human knowledge in the form it currently takes, which is as fragile and infrastructure dependent as any complex system has ever been. But to preserve in a form that survives discontinuity. Redundant, geographically distributed, format-independent, maintenance-free preservation of the most important things our civilization knows. The medicines, the agricultural sciences, the basic physics and chemistry that underlies everything we build. The record of our history, including this history. The history we are only now beginning to recover of the world that existed before the Younger Dryas, and the world that was built from its ruins. We have never seriously attempted this. We have institutions, libraries, archives, universities that preserve knowledge under normal operating conditions, in formats that require continuous maintenance to remain accessible. We have no equivalent of Göbekli Tepe, no deliberately buried, maintenance-free, format-independent archive designed to outlast the collapse of the infrastructure required to access it. We know that the deliberate burial of Göbekli Tepe preserved it across 8,000 years. We know that the information encoded in DNA survived 315,000 years in Jebel Irhoud. We know that oral traditions preserved specific geographical information across 10,000 years of transmission. These are the technologies of long-duration preservation. We understand them. We have not applied them to the knowledge base of our civilization. This is not a technically difficult problem. It is a political and philosophical one. It requires accepting the premise that our civilization might end or be severely disrupted in a way that destroys normal information access. That premise is uncomfortable. It is, in fact, one that many people resist because it implies a fragility we prefer not to acknowledge. But the evidence is the evidence. The geological record is the geological record. The genetic discontinuities are real. The impact boundary layer is real. Göbekli Tepe is real. The flood myths are universal. We are probably not the first people to have built something worth preserving. And the people who came before us, whoever they were, whatever they knew, did not preserve it in a form that we can read. They left us stones, stones with images we cannot interpret, structures whose purpose we can only guess at, arranged by people whose names we will never know, in a landscape whose meaning is entirely opaque to us. They left us stories, transformed beyond recognition by 12 millennia of retelling, of a world that was lost. They could not do better. They did not know what was coming. We do. We have the geological record that shows what kinds of events cause civilizational resets. We have the mathematical models that show why complex societies are fragile. We have the archaeological evidence that shows what survives and what doesn't. We have the physics to identify the risks, the comet streams, the supervolcanic systems, the climate tipping points. We are in the unique position of being the first civilization in the reset cycle, if that is what we are in, that knows about the cycle, that can see the pattern, that has the tools to read the warning in the ice course and the ocean sediments and the impact boundary layer at 12,900 years ago. That knowledge is either going to matter or it isn't, but it can only matter if we take it seriously. The question, what if human history has been reset multiple times, is not ultimately a question about the past. It is a question about what we do now, with the understanding that we might not be the last civilization to face the choice between continuity and collapse. The stones of Göbekli Tepe have been waiting in the ground for 10,000 years. They are still here. The people who buried them are not. What are we going to leave?